Hi everyone, welcome back to the channel. This is part one of what will be a very exciting project for you over several weeks, and it's going to be all about the process of a commission. Now, what is a commission? Sounds very familiar. I used to work to commission. I don't anymore. I just make products and of course make YouTube videos. But commissions are, generally speaking, what you start out doing if you're becoming a blacksmith. Somebody will get in touch and say, hey, I want a gate made, or I want some railings made. Can you do it? And you go, yeah, of course I can do it. So you go away and you go, right, so what sort of thing are you interested in? You come up with suggestions, and eventually, hopefully, they at some point, the clients go, yeah, okay, let's go with something like that. And then you've got to draw it to make sure that they understand that you know what you're talking about, that you also know that what you're talking about, and that they can see what they're going to be hopefully giving you a fair amount of money for. It's a long-winded process. So what is the process? Well, the process is that you design something. You finalize that design, you agree with the client that that's the design that they want to go with, that you want to go with, you think you know how to make it, and you draw it out. And you draw it out in a way that you can not only represent accurately what that project is going to look like when it's finished, but also as a way for you to understand how it's made, how much it's going to cost, what techniques are involved, if you can make it all, how you're going to make it all, and all of that. The design stage is one of the most important parts of commission work. These drawings should be your finalized idea of what is going to get made. The idea is that you end up with a fully functioning three-dimensional blacksmith forged metal that looks exactly like this. There's no point doing a random sketch, a rough idea, showing it to a client. Yeah, it's going to look a bit like that. No, you need to design it, you need to draw it, you need to know what you're doing, you need to be able to recreate what you've drawn in metal. And I'm going to show you, hopefully, how that works. Now, for this one in particular, this project is going to be a table. Now, I've got the luxury of not having any clients, so I have just picked this out of my own brain, and it's entirely my design. I'm not resigned to having to change or adapt my design to what somebody else might want. I've got a big luxury here. I get to make whatever I want. And what I'm making this time is a console table. Now, a console table is one of those sort of slightly narrow, wide tables that you often see in hallways, with a vase of flowers or a nice clock bowl for the keys or something like that. There's a lot of features in it that I know how to make. There's one or two things in there that I'm not quite sure yet how I'm going to do it. So there's going to be a bit of experimentation. There's definitely processes in there that I haven't done before, but I've been able to use the language of blacksmithing that I've learned over the years to understand roughly how I would probably do it. So there's a bit of new things in there for me as well. Hopefully it gives you a good understanding of seeing the entire process from start to finish. So I've got some drawings here. I'll hold them up briefly. We'll take a closer look at them. So this is the final design. I'll show you the bit more detail closer up in a second. But as you can see, this is one side of the side view of the table. This is the front view of the table that's been cut off because this just repeats over here. This is a bit of detail of the wedge system that I'm going to attempt to connect the horizontal to the vertical legs. I've also roughed out, now this isn't to scale, but I've also roughed out an idea as to what it will look like in a kind of three-dimensional setting. So let's go and have a look at these. I'll show you why they're so useful to have drawings like this. I'll show you all of the things that you can do with these drawings, and then we'll talk about how you map this drawing out, the important bits at least, onto a board full size that then you can work on. Okay.
So here are the drawings. Basically, we've got a side view and a front view and a bit of a detail. This is a sort of 3D representation. That's not to scale, it's just to give a bit more of a picture. These are to scale. Now, what do I mean by scale? Well, it's drawn in a 5:1 scale, which means that for every centimetre on the page, that would represent 5 centimetres in real life. So I can actually take a ruler to this drawing and measure as a reference exactly how long these pieces are going to be, because I know that all I need to do is measure this on the paper and times it by 5. And that way I can use this as my guide going forward to actually understand exactly what I've drawn, exactly how it's made, these distances, this distance, all of that is all worked out for me at the design stage. So this table is going to be made of 40 by 10, possibly 40 by 12 flat bar, okay? All the same material. This is 40 mil, that's 40 mil, all 40 mil. Riveted together with a wedge system holding this horizontal beam in place. There's some nice upsets on the end here and here that's going to add some detail. There's some nice squished down balls in here to add a bit of detail. There's going to be some swelling here from this punched rectangular hole. There's going to be a quite tight angle here and a nice sweeping curve with lots of tapering going on. Big, long, subtle tapers that should add a bit of texture as well to the material. So I've never made these wedge systems. I've seen them a lot. I quite like the look of them. And there might be a point at which I discover that you need to have a little key in place to stop them coming back apart, but we can sort all that later. This punched hole will be fairly straightforward. I'll be doing that on the fly press, but I don't have the punch that's the right size, so I'll be making a punch, making tooling for a fly press, including the bottom bolster, to get these punched holes all done. The tapering will be done under the power hammer, and the squished balls here will also be made to size. That'll be fun under the power hammer. So there are a few techniques in here that I have done lots of. There are a few techniques, one or two, that I haven't done. The most complicated thing is going to be the punched hole, the rectangular punched hole on this horizontal section here. Because if you notice, on this section, it's in line with the length of the bar. But on this section, it's going to be perpendicular to the length of the bar. But I still want a big, thick wall thickness going each side of that central wedge. I might use a slightly different punch to start off using, getting a narrow hole that I then drift out wider in that direction, as opposed to the punch for the vertical, which is going to drift out widthways, if that makes any sense. All of that's going to be a lot clearer as we get further down. The next step is going to be to draw this out on a piece of board full size. Now, I don't need to draw all of it out. This is just a horizontal bar. I don't need to worry about that. It's going to be a fixed length. This, as I said, is a mirror image of that, and this in itself is a mirror image of the second upright that's going to go on the other end, here and here. So really, all we're doing is needing to draw out one of these feet. So if you imagine a line going straight down the middle of that, all I'm going to be doing is drawing out the relevant section, full size, on a piece of board. Now, why board? Well, board's hardy. Yes, it burns, it's wood, but I'm not going to be putting a lot of hot material on it. The benefit of it is that I can mark out this curve really, really accurately. And once I've marked out that curve, I can then cold bend a piece of material to match the inside of that curve. And what that allows me to do is then create a jig that I can weld to this table, which would allow me to bend this curve 4 times completely consistently. I can get this angle figured out because that's going to be an angle put in first, and then this leg's going to be curved around. I can then make sure that all of this straight piece is clamped to the table, clamped to the jig, and I can come along here and get a nice even curve in and replicate that each time. So what I'm going to do now is I'm going to set the camera up, I'm going to get a board out, and I'm going to show you the basics of how to draw that, which hopefully should be self-explanatory. So I've got quite a scruffy looking old bit of board here. Don't worry too much about that, about how scruffy it is. It's going to get way scruffier, but just to give you an idea, it doesn't need to be dramatically flat. It doesn't need to be brand new. This is, I think, about 6 mil thick, something like that. Just cheap plywood, cheap as you like. It just needs to be rigid. You need to be able to see marks on it. Obviously, just double check that it's big enough. That's plenty big enough for me. Quite a basic straight rule. I've got a set square, well not a set square, a big drawing square here, and I've got my big pencil. Because it's an old board, I'm going to assume that nothing on it is square. I'm going to start by doing what I call a datum. Now a datum is one fixed point that you can work from, that everything else comes off of. So I don't need to worry about this being square, the distances, anything. I know that my one line here, that's my line, that's my datum, that's where I work everything from. And what I'm going to do is I'm going to draw one that's going to represent the middle centre line going right down the centre here. And that way I can work everything else off from it. Now this doesn't need to be square to the board at all, because like I say, it's going to be its own datum. But what I want to do is just create that line. Now that line is the line that I'm going to work from. And what I'm going to do is I'm going to pick a point, knowing that I've got enough distance. I need about 800 mil high, so that will be fine for me. So I'm going to mark a point there arbitrarily, and I'm going to make a square, a line square from that line. So I now know that this is the floor and this is the centre line. So everything else that comes off it is going to come off from this centre line here. Now what I'm going to do next is I'm going to measure up from this point, and I'm going to mark 800, because that's the total height of my table. And again, I'm going to come out square to this back central line. Now what I'm going to do again is on here measure out half of 300, so 150 from this back line again. I'm going to mark that point, and I'm going to do the same up here. 150. Now what I'm going to do is I'm going to measure from this point that I've just drawn to that point that I've just drawn, and double check that that is 800 mil, which it is, bang on. Now if you're really paranoid, what you can do is measure from corner to corner, and that will give you a very accurate idea as to whether this is square. So that looks like 814.5, and again from this corner to there is 814.5. So I'm very confident that this is now as close to perfectly square as I need it and can get it. So that is my working section for each of these halves. So I'm going to go around, I'm going to mark all these up. You'll see that all happen quickly, and when I get to about here, I'll show you how I mark that curve out. So that's my top section drawn out. What I need to do now is develop this curve for these legs coming down here. This point here is going to connect with this point, which is the very bottom corner, which is here. But the inside is going to connect somewhere arbitrarily along this line. Now it's not going to be 12 mil, because like I say, it's going to be tapered. Now I'm going to aim to get it down to about 6 mil. So what I'm going to do is I'm going to mark 6 mil there, back from that line. So now I have my starting point and my end point. Okay, and how do I get a nice free-flowing curve going down there? Well, the easiest way is to use an aluminium rule. Okay, very flexible, likes to hold its shape to a certain extent, but for this job it's absolutely perfect. And what I can do, it's a bit fiddly, but because of the elegant nature of that curve, I want that curve to end up in a vertical plane. So I'm going to hold this as if that's a continuation of that vertical line going down. And with that end held close to that point, I can curve this up to that point. And that's going to give me my nice elegant curve. The tricky bit is that there's only one of me, and I've only got two hands. So what do I do? Well, this is where you have to be a bit Keith Robinson about it. Now I found that something like that works very well, allowing me to match that curve. As you see, that's a nice, elegant, flowing curve. See how I've sort of gone over this line quite a lot, whereas this one, the inside line, I want it to be a bit more accurate. So I've just done one there, but the reason for that is that I want to use this line, the inside line, to work out a cold bent piece of steel that's going to end up being my jig. Also, what's really useful about this is that it allows me to take that angle. So if I approximate that curve there, put a straight line against it, I can draw that straight line there just lightly, and then that allows me to work out what that angle is. And once I've worked out that angle, I can bend that in a bender, two straight pieces, and then I can form this curve around the former or jig that's going to get made up for that. So how do I work out accurately the length of this curve? Now you might think, well, I could just measure it with a ruler. You might be right. Some curves you could get away with doing that. But if your curve's a bit more complicated, you know, even if it's multiple curves, what you need to think about is something called the mean line. Now the mean line is the line that travels through the very center of this curve. If you imagine a point there and a point there, so literally going all the way through that curve. Now I could draw that again with this ruler, same technique. So the other thing to do is to use dividers. If you set your dividers to a known length, so I know that each one of those is 20 mil. And if you stick to your mean line, you can work it out. 20, 40, 520 at that point. Now I can take my ruler, measure the last two. So 523 millimeters. So I know from that point, $523 millimeters. That's a straight line. I can just use my rule. So that is 294. So from that point to that point, 294 mil. And from this point to the very end is 140 mil. Again, I'm going with the mean line here. That's 140 mil. The true length of this piece of material is that plus that plus that. So 957 is the total. You're going to shout at me in the comments if I've got that wrong. Please do. Pretty sure that's right. But I don't know how much that punch hole there, that upset there, that curve there, that taper there, and that curve put in is going to affect that total. So 957 is the true length. Okay, TL, true length. That means after I've worked out all of these other processes and I've forged all of these things out, I know that my piece needs to be 957. So what would be next would be to work out exactly what happened when I put this upset in. How much shorter the material gets from forging that upset. When I punch that hole, what happens? Does this material get longer or does it get shorter? When I put that angle in, does it change? When I forge this taper out, this material is going to get longer. What length of parent material do I need to forge a taper out to be 523 mil long? Those are the unknowns at this point, and that's the point of test pieces, and that's what you're going to see in the next video.
So hopefully now I've given you a really good understanding as to why it's so important to have really good designs, really well thought out designs, and just how much time and energy and money, most importantly, that will save you for a project like this. I also showed you how to draw things out on a board and why that's so important. In the next video, we're going to be talking about test pieces. Now I'm going to get the forge lit, so it's going to be a bit more blacksmithing next time. Apologies, this one's been a little bit talky and not very much blacksmithing, but that's all going to change now that all of these headaches have been worked out. What we've ended up with is finding out the true length of each of one of these four pieces. Now that's a really important part of this process. The unknowns that we still have are the changes to the length when I put in all of these forged features, and that's going to need test pieces. Getting a length of 40 by 12 like this and putting the upset on that I want, what does it do to the length of that material? I need to test that. I need to record that. This bend, this curve, this taper, this punched hole, all of these things, they all have an impact on the length of the material that you end up with. By how much, we don't yet know, and that's the point of test pieces. We're also going to be talking about jig making. And that's a really important part of a project like this. A real useful part of a blacksmith skill set is being able to create a curve or a shape or a series of curves and being able to replicate that time and time again. So it's really important that you see how to do that. So we're going to see how all of that works in the next video. Any questions or points that I haven't covered that you think you'd be a lot more interested in hearing about, please write in the comments. I'll happily get back to people about that. Thanks for watching. Please subscribe. You'll see the next video pop up if you do. It's going to be a lot more forge work, a lot more heat, and a lot more interesting things going on. But I hope you found these things really useful.